Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and we are continuing our advanced algebra video series by looking at perfect squares, and this is the 9th video in this series. So in this video what we're going to cover is a definition of what a perfect square is. I'm going to show you a shortcut to expanding perfect squares, a shortcut to factorizing them, and do some worked examples. Let's get straight into it and talk about what a perfect square is. Well, a perfect square is an algebraic expression in the form of two values inside brackets. They could be added or subtracted. In this particular example, we've used addition. And there is a squared symbol outside the brackets. Now, a and b could be a combination of letters and unknowns, such as x plus 3 to the power of 2, or 2m plus 5 all squared, or even 3h minus j all squared. So it could be letters and numbers, or two lots of letters and numbers, or combinations as well, pluses and minuses. So it looks like this: two variables, brackets, squared. So whenever you see that squared, that should ring that bell for you. This could be a perfect square. And then we're going to show you how to expand that really quickly. Now, firstly, it is very tempting to think that the answer is going to be a squared plus b squared. Square the first term, square the second term. And this is a common mistake that people make. However, it is not correct. The reason it's not correct is that a plus b all squared is the same as a plus b in one set of brackets, a plus b in a second set of brackets. It's basically being multiplied by itself. And when we expand that out using FOIL, first terms as a times a becomes a squared. O is our outside terms, A and B, so that becomes plus AB. Insides, for the FOIL part there, is A times B, and lasts is B times B, which is B squared. Now, in that centre part there, we've got two lots of AB, so that becomes 2AB when we simplify that expression by collecting our like terms. So we can see straight away that when we expand a perfect square, we're going to get a three-term answer. A squared plus 2ab plus b squared. It is not going to expand to just a squared plus b squared. That's a no-no. So just be remembering that it means two sets of brackets multiply by each other, and there's that FOIL process for expanding. You could always use that FOIL process to expand that and you will get to the right solution. However, there is a shortcut to jump straight from here straight to the bottom here. So our perfect square produces a result that is, firstly, the first term squared, which is a squared, and then 2 times term 1 times term 2. So a times b, which was ab, and double it, timesing it by 2 makes 2ab. And our third term squared. So that's what our final answer is going to be. The combination of first term squared and then 2 times a times b, then b squared. So let's follow this now with m plus 5 all squared. Okay, so remembering that it means m plus 5 multiplied by m plus 5, it's not going to be m squared plus 5 squared. Okay, so following that little shortcut process, we'd square the first term. The first term is m, so m times m makes m squared. And then the second part, remember, was this part here times this part here, and then times that by 2. So 5 times m makes 5m, double it makes 10m, and then we're going to square that last term. 5 squared makes 25. So this bit here, 5m plus 5m, becomes 10m. So that's our shortcut there. So let's use our shortcut again with this one, y plus 9 all squared. So remember, first term squared, then second term and first term multiply by each other. Y times 9 makes 9y, and then double it makes 18y. And then our last term, 9 squared, makes 81. So we've basically finalized it. Okay. This is the same sort of thing. The only thing that's different here, instead of just a k by itself, we've now got a 2k. So once again, if I'm going to square that first term, then I have to square the 2 as well as the k. So that becomes 4k squared. And then I'm going to take this term, multiply it by this term, and then double it. So 4 times 2 makes 8. Double 8 makes 16. So it'll be 16k. And then the last term squared, 4 times 4 makes 16. Okay, so hopefully you're seeing the pattern and you're being able to work out really quickly how to get there. You could, like I said before, you could expand it using FOIL. It will just take a little bit longer. This cuts out a step, basically. All right, we're trying another perfect square now with a subtraction. So first term squared is j squared. Minus 10 times j makes minus 10j, times it by 2 makes minus 20j. And negative 10 times negative 10, remember a negative times a negative makes a positive, so our final term will be plus 100. Okay, so when you've got that subtraction in the brackets, you need to be very careful. Anytime you see subtraction, be careful. So in this particular case, positive times a negative makes a negative, and we're timesing it by positive 2, it's still a negative, and that's why there's a negative here. But negative 10 times negative 10 makes positive 100. Now the problem is a lot of people don't know their times tables, so they put minus 10 into the calculator and square it. You could have a go at doing that now. Chances are your calculator is going to do negative 100, and the reason for that is your calculator needs to be told to put the minus 10 into brackets. Otherwise, what it's going to do is 10 times 10 and then times negative 1. So I know that sounds a little bit confusing, but just remember, anytime you're multiplying a negative by a negative, you should end up with the positive. So that's our little fact check there. Okay, so these are true rules. If you don't remember those, write them down now. Okay, now let's assume we've expanded an expression out. Now we want to get that shortcut back to factorizing. Okay, so we saw that a plus b all squared expanded out to this is our final solution. So if we have something that looks like this, we should be able to get that back into perfect squares fairly easily. Here's how we do that, if that's our starting point. Well, firstly, we need to know our perfect square rule really well. So you need to memorize this, expanding to that. I would say write it on a piece of paper, stick it on your bathroom mirror or your bedroom wall, and start to recognize and keep looking at that so that it becomes really familiar to your brain when you see something in that form. Okay, so the first way to go about factorizing it, which means putting back into brackets, is when you get something like this, you look at this number here and this number here and ask yourself, are they both squared numbers or squared values? Well, because we're using letters, yes, they are both square. But if this was, say, the number 100, 100's a square number. So knowing your square numbers as well is really important to give you that clue that you're looking at perfect squares. So then what you need to do is check that if you multiplied the square roots of these numbers by each other and doubled it, would that get you here? Now that sounds a little bit confusing. We're going to try this with an example and you'll see more of what I mean. So first we're going to ask ourselves, is this a perfect square? Well, firstly, a squared is a squared term, and the square root is a. And this last number 4 is a squared number as well. The square root of that is 2. So my question is, are the first and the last term squared numbers? Yes. Okay, let's keep going. Now, does the square root a and the square root here 2 times a makes 2a, and if I double that, 2a times 2 makes 4a, is that going to be my center term? Yes. So I know now that this is a perfect square. It does. Okay. And the factorized solution for that would be a plus 2 all squared. This number here inside the brackets, and a squared on the outside. Here's my next example. Factorize m squared plus 6m plus 9. So we're going to follow this same process again of just checking to see firstly, is it a perfect square? I know m squared is a squared value because the squared gives that away, and the square root is m. Looking at that last number, positive 9, is that square number? Oh yes it is. The square root is 3. Now let's take these two square roots, m and 3, multiply them by each other, I get 3m, and double it, I get 6m, which is that value in the middle. So yes, I know I've got a perfect square. So what I'm going to do next is I'm going to take this value here and this value here, which is a positive 3, put them inside brackets, and then square it out the outside of the brackets, and I'm finished. Let's look at another example. This one looks a little bit more complicated. First of all, let's look at that first one there. We know this part's a squared number, and so is 16. The square root of 16 is 4, so the square root of this part of the expression is 4y. Let's look at the last value, 25. Is that a square number? Oh, yes, it is. Square root of 25 is positive 5. Okay, so now I know squared number, squared number. Let's check this number in the middle. 4y times 5 makes 20y. Double it makes 40y. Yes, I've got a perfect square. So now I'm going to take this value and put them into brackets and square them as well. And that's my factorized solution. Once you see the pattern and you get the pattern, it becomes super easy and it makes it really easy to factorize these bad boys. So learn that pattern and you'll be home and host. Well, did you find this video helpful? I sure hope so. If you did, here's some ways that you can engage further. You can first of all like and subscribe. Hit that notification bell and you'll know when I've got the next video in this series ready for you to watch. You could share the video with someone. Why not? Click on that little share button, that little arrow, send it to your teacher, put it on your class OneNote if you are a teacher, or just share it with a friend. You can follow us on social media, on Facebook and Instagram, or you could tell someone about this video. And why not tell us? Why don't you tell us in the comments what you thought? We always love to see your feedback. You can even consider a super like. We do spend a lot of money on the channel getting these videos ready for your viewing, purchasing software and the like. So why not consider giving back a little? It's a super like button. You can find that there. Give a buck or two. It always helps us. And if you've got any questions at all whatsoever, mcclutchymass@yahoo.com, best place to deal with those. Comments is not a great place for asking questions, but this is where I can give you my undivided attention and let you know if there's something you need help with. Well, thank you so much for watching today. Appreciate your time. I'm Natalie McClutchy. Have a wonderful day.